We got it. What? Okay, we will finish before that, yes. Oh, it will be a lot. Let's see. So now we will begin. Okay, first of all, what is it? Yeah, one of the problems previously was this one. This was y is equal to m1x, and this was y is equal to m2x. These were reciprocals of each other, and this line was x plus y is equal to 1. And you had to find that, right? So in 1c, I suggested the coordinate system u defined to be x plus y, and v defined to be y over x. And that makes this particularly easy to do because on this line, y over x is equal to, so y is equal to m1x, if and only if y over x is equal to m1, if and only if v is equal to m. Sorry, u is equal to m, and y is equal to m2x. No, sorry, v. Yeah, that thing. Okay, and y is equal to m2x if and only if y over x is equal to m2, which means v is equal to m1 and v is equal to m2. If a coordinate is constant, it's a grid line. And x plus y is equal to 1 if and only if u is equal to 1, which means I have this is this. I will draw another picture. This has now become a rectangle. Its sides are bound by u is equal to 1, v is equal to m1, and v is equal to m2. If u is equal to constant, we get these lines. If v is equal to constant, we get these half rays. So this is a coordinate system, and this coordinate system is best suited to this particular problem because the area in question has become a rectangle. Why is it a rectangle? It is bounded by curves along which the coordinate is a constant. And therefore, to find the area is particularly easy. Okay? So the next problem 2c was to see whether you can whether you have understood this idea, and the answer to that is no, you haven't. This equation was xy is equal to 1. This line was y is equal to m1x and y is equal to m2x. So if you compare this with the previous example, where this one was x plus y is equal to 1, this one was y is equal to m1x, and this was y is equal to m2x. Here I defined u is equal to x plus y, and v is equal to y over x. If you look at these two and just blindly use the analogy, what should the definition of u be, and what should the definition of v be? No, there is no x plus y over here. You want to make this. What is constant along this line? Along this line. Yes. What is its equation? Is given right next to it. Well, Is 1 a constant? Yes. What is this equation? What, rather than the curved line, we have a straight line. What is constant along the straight line? This line. Well, x plus y is constant. We took u is equal to x plus y. So what should we take u to be in the other case? Of course, we take u to be xy. These two lines haven't changed. So v should still be y over x. And you should try to work this problem out to see if you get the answer. Riviera, you have a question?
No.
Okay, so that's the first point that I wanted to make. Next point about the tricylinder. So you have x squared over a squared plus y squared over b squared is equal to 1. Y squared over b squared plus z squared over c squared is equal to 1. Z squared over c squared plus x squared over a squared. But actually, let me write it x squared over a squared. Z squared over c squared is equal to 1. So I wrote a very detailed set of instructions for this one. Okay, so I said first define x over a is equal to u and y over b is equal to v and z over c is equal to w. If you do that, then this becomes u squared plus v squared is equal to 1. V squared plus w squared is equal to 1. And w squared plus, x squared plus w, not u squared plus w squared is equal to 1. No, u squared plus v squared plus w squared, u squared plus w squared is equal to 1. Okay. So note that this means that x is equal to au, y is equal to bv, and z is equal to cw. A, B, C are different for different people. Okay, so now how do you solve this? You do something else. You define f is equal to u squared, g is equal to v squared, and h is equal to w squared. So you get f plus g is equal to 1, g plus h is equal to 1, and f plus h is equal to 1. Okay, so now you have 1, 1, 0, 0, 1, 1, 1, 0, 1. F GH is equal to 1, 1, 1. From which you can conclude that the augmented matrix of the system is 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. You know how to solve this equation, right? So that will give you 3 roots. That will give you 3 roots. Okay. So those 3 roots will give you f is equal to u squared is equal to something. Let me call, what shall we call it? Capital F. Right? That means u will be equal to square root of f, or u is equal to minus the square root of f. Okay? Same thing for v and w. So this will give you 6 points. This will give you 6 points because you will have all the different combinations, plus and minus for each of them, right? Sorry, this will give you 8 points. 2 times 2 times 2, right? Yeah, because, so let me say G, G is equal to V squared is equal to capital G. So that means you will of course work with numbers. V is equal to square root of G, or V is equal to minus the square root of G. Similarly, the H is equal to W squared is equal to H, which means H is equal to square root of H, or H is equal to, not H, W. W is equal to, actually I should write the minus first, not minus last. So this is minus square root of H, okay? Which means you will have plus, minus, etc. There will be 8 of them, right? Okay, but Byron, how many are there? There are
14 altogether.
There are 4. So we are missing 6. Where would the other 6? Where are the other 6?
The other
other
6 are
Yeah.
the of just 2 cylinders. So this is the intersection of 3 cylinders. We then have
Yeah.
to add in when you
Yeah.
just have
Yeah. Yes, the intersection of 2 cylinders will give you the other points. You see, which are on the axis. So there are the positive axis and the negative axis. So those would correspond to, if U squared plus V squared is equal to 1, V squared plus W squared is equal to 1, and U squared plus W squared is equal to 1. Each axis corresponds to 2 of the coordinates are 0, right? So let's take the z-axis. So z-axis is defined by x is equal to 0, y is equal to 0, right? Okay, so that would mean that u is equal to ax is equal to 0, v is equal to vy is equal to 0. That means so u squared plus v squared is equal to 1 doesn't work for that. You would get from this equation, w squared is equal to 1. You get from this equation also that w squared, so let me write it properly. U is equal to 0, v is equal to 0, and u squared plus v squared is equal to 1 together lead to a contradiction. So we cannot consider the first equation in that case. So u squared, u is equal to 0, v is equal to 0, u squared plus w squared is equal to 1, v squared plus w squared is equal to 1, lead to w squared is equal to 1, which means that w is equal to minus 1 or w is equal to plus 1, right? But which means that w is equal to, what was w? X over c, right? Z over c. Z over c is equal to minus 1, or z over c is equal to plus 1, which means in turn that z is equal to minus c, or z is equal to plus c. So bad picture. This point is C00, and right underneath that point is minus C0, sorry, 00C, 00C. And that point right underneath is 00 minus C. Okay? So these are the points at which this intersect. So from here, this curve, so it's this way and this way, that point at the top. Okay. So on each axis, there should be such a vertex. And there are how many of those? 6 of them. 8 plus 6 is 14. Okay. Clear to everyone? Now we have to find the edges. So edges correspond to the intersection of 2 cylinders, right? So what did we have? F plus G is equal to 1 and G plus H is equal to 1. Here too we can use our old technique, 1 1 0 0 1 1. FGH is equal to 1 1, which means that the augmented matrix is equal to 1 1 0 0 1 1 1 1. Okay, from which there are how many equations are there? 2 equations in 3 dimensions. So how many parameters do you get? 1 parameter. We can call that parameter T, for instance. So that would give you these curves. This curve, for instance. Okay, so the parametrization is really very easy, although you should do it using this technique. Okay, but it is obvious what the parametrization will be. If F plus G is equal to 1 and G plus H is equal to 1, it is clear that F is equal to 1 minus G and H is equal to 1 minus G. Right? So obviously it means that this will be the parameterization, 1 minus T, 1 minus T, T. Okay? But now we have to be careful because this is equal to U squared. This is equal to V squared. And this is equal to W squared. Clear so far? And that in turn is equal to X squared over A squared, Y squared over B squared, and Z squared over C squared. If you take the square roots, you would get U is equal to either minus the square root of 1 minus T, right? Or U is equal to, plus the square root of 1 minus T. Similarly for V, V is equal to minus square root of T, or V is equal to square root of T. Okay, so this will give you many different cases, and you have to again consider all the possible signs. And that would give you the different edges. Is this clear? But you have to make sure that you understand which edge goes from which point to which point. So you will have something like this. You will have a list of vertices. So if you have a vertex V1 and a vertex V2 and the edge V1, V2. Okay. So you have to list all the edges and all the vertices. And then how do you list the faces? The faces are bounded by 4 edges. So the best thing would be to get Byron's model or make a paper model and see which vertices correspond to which edges and so on. Okay? And then you know how to find the length of an edge because that's just a line integral. How do you find the parameterization of a face? The parameterization of a face, it's just a single cylinder, right? So something like the first one. U squared plus V squared is equal to 1. So the first cylinder, actually, let's start from the right place. So this cylinder was x squared over a squared plus y squared over b squared is equal to 1, from which we got u squared plus v squared is equal to 1, from which we got f plus g is equal to 1, right? F plus g is equal to 1 is there for the equation, which we're trying to solve, which will be 1, 1, 0, FGH is equal to 1. Right? Which means we get the augmented matrix is equal to 1, 1, 0, 1. One equation in free space, which means how many parameters? 2 parameters. So from this, it is, and this is already in Emit form. So we can take F is equal to, so if I use T for the lines, let's use P and Q for this, P, Q, and R. Okay, I can take F is equal to 1 minus P, G is equal to P, and H is equal to Q. PQ in R2. Okay, but then you again have to take square roots and multiply it by ABC to get XYZ. And this would give you, depending on the choices of signs, all the faces. Byron, how many faces are there?
There's 12 faces.
12 faces. So there you will have 12 possibilities. It is crucial to make a paper model. There is something on folding and unfolding that I sent you that would allow you to make a paper model, or just use Byron's model, or a picture of Byron's model with the edges marked in some other color. Yes, no. I sent it. Yeah, on this general email that I sent you. The PS, it is in the, no, it is not in the PS, it's in the regular thing. In the first email that I sent last night. Yeah, folding and unfolding. So what is crucial is to have the model and mark the points, A, B, C, D, etc., as I have instructed you to do, and then see which numbers go in which places. In other words, it should be an experimental effort to make sure that what you see corresponds to what you have on paper. Is this clear to everyone? Okay. Okay. Now you would have to integrate. Find the line integrals along the lines and get each of the lengths. And there are 24, right? Byron? 24 edges.
Yeah, 24 edges.
So you will get 24 numbers, but because of symmetry, some of them will turn out to be the same. Okay. And then the faces. Faces would be surface integrals. You see, do you understand? And the volume, of course, you should find 1/8 of the volume and then multiply by 8. And the volume is worked out in many different places, except that you have to translate into my setup. Okay, so this is a problem that is definitely doable. I suggest that all of you meet together along with Byron's model and paper models, and that all of you work out in terms of ABC. At the very end, plug in the ABC, because I meant this to be a joint project. Is this clear to everyone? Okay, I will be very happy if you can all get 50 on this. Okay, and the other thing that I wanted to say, this I can't do. Ideally, there should be a lab in which you actually take a piece of string, put it on the paper model or on Byron's model, then a wet string. Then you snip it, then you measure the length of the string using a ruler and see that the answers that you calculated actually correspond to what you get. You can do the same thing with the faces. You can put wet cloth and then cut it. Okay, this will work perfectly because this is actually just a ruled surface, which means that it can be flattened out. That's why you should look at the foldings and unfoldings. Okay, so you could actually measure the area of the cloth and compare that to what you calculated. For the volume, you take Byron's model, take a measuring cylinder, fill it with water up to a certain point, dip the thing in it. So it will displace a certain amount of water. So Archimedes' principle will give you the volume. And then you calculate and see that it actually corresponds to that. Okay. Incidentally, yesterday I sent you papers about sections of ellipsoids. No one has read them yet, but I sent it to you. One of the Wikipedia article on ellipsoids mentions one medical use. All of it, I think this class consists entirely of men, right? Yes, yeah. So all of prostate glands. How does one measure the volume of the prostate gland? You understand what the prostate gland is? A gland that surrounds the urethra, and it grows like this. So if it grows too large, which happens with everyone, then it blocks the flow of urine. Clear to everyone? Because it's sort of like an ellipsoid with a hole in the middle. So the ellipsoid is growing, which means the inner radius is decreasing, the outer radius is increasing. So when they measured the size of the prostate gland, there are two techniques which are in use in the United States now. One is that they use ultrasound to make a picture where they put it in various places of your abdomen and look at the pictures, but you get a two-dimensional cross-section. From that, they estimate the volume and they use the formula of the ellipsoid, volume of the ellipsoid. So this is direct practical application. Okay, the alternative is to use it's called an endoscope. Oh, you have to. Yeah, the endoscope is inserted through the anus till it can reach up somewhere near the bladder, and then you take a three-dimensional picture. That's the second method of doing it. But in both cases, you have to use the volume of the ellipsoid. Clear? So all of you are in your 20s now, some are in their 30s. Eventually, when you have to have a colonoscopy or a prostate examination, you should look at what they have done to find the size of the prostate. And you should read the Wikipedia article, which actually gives you the formula. Okay? So I was surprised but a bit pleased that it lists that use. So is this clear to everyone? Yeah. So I suppose in an ideal world, I could have had you go and perform ultrasonography on each other, look at the picture and measure the size of your prostate. That would be a very good exercise for this class. Okay.
No, thank you. That does not sound fun.
It is it, of course. You must know about the topology of your body. So most people would not have the prostate measured at this age, but if you did, you can in fact find out the differential rate of growth. It is growing, yes. Yeah. I don't think that there is any actual data on the differential rate of growth. But I told you that it is extremely important to understand the topology of your system, so that you know the ins and outs of your body very, very well. And this is purely a problem in three-dimensional geometry. Okay, except that we deal with rigid objects, and we are not rigid. The bones are the most rigid stuff that we have. Okay, okay. So we will not go as far as actual measurement of your prostate glands, the size of your prostate gland, but the tricylinder will do for the moment. Okay. No. You see, if I had my way, I would teach you everything up to 272. Then I would teach you physics. And then in the physics classes, I would have you perform these experiments. I mean, they're useful. How would you find the volume of your heart, for instance? Or the speed at which it pumps, or rate at which it pumps? Yes, because they kill the subjects altogether. You will not have a bad experience with physics private teaching. I would have.
Tell us like when the proper day the test will be.
Oh, well, I produce the opposite kind of nightmare. In which you know. Yes, so the nightmares are different in content. So, okay, that settles this one. Do you understand what you have to do? Okay, and again, the surface areas are not calculated anywhere, but for as soon as I made the first transformation, the u squared plus v squared is equal to 1, v squared plus w squared is equal to 1, w squared plus u squared is equal to 1. That is done in many places throughout the internet on Wolfram math and so on. Okay, but the ellipses are not worked out and they don't use linear algebra as I'm using. But you should use linear algebra so you understand the whole thing. Clear? Okay.
Yes.
Now a little bit more, but for Riviera, you had a question? Riviera, do you have a question? Or Riviera went silent. Byron, do you have a question?
Oh, just turned off.
I beg your pardon?
Yeah, so I was saying I have to leave because I just got to my destination. So I wanted to say goodbye.
Okay, very good. So we will talk again.
All right, sounds good. Bye, everyone.
Bye. If you can come next Thursday, please do. That's the last class.
I'll see what I can do.
Yeah. Okay. No, you have a lot. So, but if you can, do. Okay. Now, okay. Now I have to tell you about the problem, the thing on the problem set. Now, for that, I have to go and look at the problem set. Now, I am sharing this screen through this screen. They can only see the iPad. So it wouldn't hurt if I were to change the view and go and look at my problem set. Documents. Where on earth is it? It is here. Exams. Exams 271. Problem set. Okay. Okay, for the problem set, let's see. For the problem set, let's go directly to, yeah. It's problem 2. Consider the coordinate system. It's the spherical coordinate system in 3 dimensions. Okay. So find the level surfaces for the coordinate system and ER, E theta, E phi, the Jacobians, etc. This one is also done almost everywhere, including the Schon's outlines. Okay. So this you should work out, but I will not do this one. I just want to point out something. R is equal to, no, X is equal to Y is equal to Z is equal to, Z is equal to R. I don't know if this is the one over there, but let's see. If I call this angle theta and this distance R, then this distance is, this is R. So this distance is, no, I won't call that theta. Let me redraw. This is spherical polar coordinates. So we will call this angle theta. This point is X, Y, Z. This is R, this distance, and this angle is theta. So this is Y0, Y0. Y-axis, X-axis, Z-axis. So this point is 0, 0, Z. And this point is X, 0, 0. So this distance is R cosine theta. This distance is R sine theta. So this is R sine theta. R cosine theta, this angle is phi. So R cosine, R sine theta, sine phi, R sine theta, cosine phi. So this is the polar coordinate system. I'm not writing down the ranges of theta, phi, etc., which is done in the notes and also in many books, including Dineen. Yes, yeah, or spherical polar coordinates or spherical coordinates. Okay. If I call that angle theta, that would have defined, no. This is actually used in geography also. Theta is the low battery. How can it be low battery? It's, oh dear. Okay. Okay. So now, how would you solve for, oh, this is cosine theta. Cosine theta, yeah, because if that is R sine theta, this distance is R cosine theta. Okay, how do you solve for theta, phi, and R? How do you get rid of sine theta and cosine theta? There's only one equation. Sine squared theta plus cosine squared theta is equal to 1. Similarly, sine squared phi plus cosine squared phi is equal to 1. So x squared plus y squared is equal to r squared cosine squared theta cosine squared phi plus r squared cosine squared theta sine squared phi is equal to r squared cosine squared theta cosine squared phi plus sine squared phi is equal to r squared cosine squared theta times 1, which is equal to r squared cosine squared theta, which means that r cosine theta is equal to square root of x squared plus y squared. Okay? We don't take the negative root because r is always positive. Okay? X squared plus y squared plus z squared is equal to r squared cosine squared theta plus r squared sine squared theta is equal to r squared cosine squared theta plus sine squared theta is equal to r squared times 1 is equal to r squared, which means r is equal to square root of x squared plus y squared plus z squared. Clear? Z is equal to r sine theta and square root of x squared plus y squared is equal to r cosine theta. If you divide one by the other, you get z over square root of x squared plus y squared is equal to tangent of theta. If you take arctangent of both sides, you get arctangent of z over square root of x squared plus y squared is equal to arctangent of tangent of theta, which means theta is equal to arctangent of z over square root of x squared plus y squared. Okay? And x is equal to y is equal to r sine theta sine phi, x is equal to r sine theta cosine phi. Therefore, y over x is equal to tangent of phi, which means phi is equal to arctangent of y over x. So now I have found all of them. So r is equal to square root of x squared plus y squared plus z squared. Theta is equal to arctangent of square root of, what was it? Yeah, square root of z over the square root of x squared plus y squared. And phi is equal to arctangent of y over x. Okay, so now let me, battery or time? At 6%. Okay, then let me just point out where it is. This is in the notes. So, where is the handouts? Okay. I will point out where it is. 271. 271, where is this stuff? Coordinate systems. It's in coordinate systems, I think. Spherical coordinate, okay. So first of all, page 5 of coordinate systems has the Jacobian worked out, which you are supposed to calculate. And the volume element worked out. Then you have to use the formulas. So look at the example on page 7. Page 7 example. That's what you have to use. And of coordinate systems. Yeah. And all the calculations are done for the polar, for two-dimensional polar coordinates. And the general formula that you need, formulas that you need are on so these are on page 2, and 3. Page 2. Page 2, 3, it's, yeah. So you look at example on page 7, and the calculations are exactly the same as those. Okay, so I will stop here. On Thursday, I will point out how this is to be done. Okay, because the battery is almost over. Let's see. Any questions? Those of you who are still in. Byron, any question?
Just let everyone know I'm gonna bring in not just one, but a couple models of the tri-cylinder on Thursday.
Okay. Okay. Usual, are you? Any
Yeah,
questions?
I'm listening. I'm listening.
Okay. Do you know what you have to do?
Perhaps.
Perhaps. Okay. Okay. So on Thursday, please come. Byron, well, we don't know if you will be in good health or not on Thursday.
I
Byron?
should not. I will stop by, drop stuff off, and then leave a couple hours in advance. I'll stop stuff off early in the day. So if there's anything,
Okay.
it'll be clean by the time anyone touches them. So
Okay. Yes, but you had better arrive with the iPad and the ID and try to come here, get here by 5. Okay? Yeah. Or before 5:30 is what I should say, so that we have a little more time. Yes. Yeah, then you should come much earlier. Okay. Any other questions? Okay, then we shall stop here. So it was very good to see you. So please, all of you have one responsibility, Nathan included. Tell all the computer science people to take 163 during the summer, if they are leaving. Okay? Nathan, do you have any? Do you have any connection with the computer science people? No? Oh, this is going to die any time. Okay, I had better end this. Did you stop the recording? Okay, I will